All right, guys, so today we're going to talk about two things. We're going to talk about radicals. We're going to review some properties of radicals. But then we're also going to talk about special right triangles, which, like, almost everyone here was taking, if not everyone, was taking geometry 2 years ago, if you recall. And typically, we start special right triangles around March. So that would have been March 2020. So there's a good chance that you did not quite learn these or never learned these. So we're going to go over them. Don't you worry. But you would have learned them around that point in time. That's definitely what we were doing. I was teaching honors geometry 2 years ago. That's what we were doing. Kind of got cut off right in the middle of it. So anyways, first I want to do some properties of radicals. This is standard 12, by the way. So first, simplifying radicals. This is a little bit related to, not a little bit, we did a little bit of this just now. But like, go ahead and do this here as a warm-up. And we'll see what we need to talk about. Simplify those radicals. All right, let's take a look. So there's basically two ways that you were probably taught how to do this. I'll show both of them. The way that I prefer to do it, because it's a little bit shorter, is if you can figure out what is the largest perfect square that goes into a number using division. So what is the largest perfect square that divides into 32? 16. So this would be 16 times 2. And so that's root 16 times root 2. And what is the square root of 16? 4. So this would be 4 root 2. Okay, so the answer to the second one's just 4. Right? Okay, that's one way to do it. The other way to do it is to break it down like all the way into all of the factors, which ends up just being like a lot of 2's. So this is, 2 times 16. 16 is 4 times 4. Or thinking about it like, okay, anytime you see 2 of a number, that number comes out. So there's 2 4s, so 1 comes out. So there's kind of like a few different ways to do this, really. But okay, so a 2 is going to come out, another 2 is going to come out. That gives us 4 on the outside. Left inside is this 1, 2 right there. We're getting 4 root 2. Different ways to do it. So square root of 24. What is the largest perfect square that goes into 24? 4. This is 4 times 6. And so I'm going to keep showing my way because I like it the best. I think it's the best way. Square root of 24 means square root of 4 times the square root of 6. Square root of 4, 2, and square root of 6 we can't simplify. Any questions on that process? Of course, the larger the number, it gets a little bit more difficult. Okay, so let's think about multiplying, because we're going to use this one a lot today. Let's say we have root 2 times root 6. Give that one a try. Okay, so when we multiply, both of these numbers are in the radical. What does this equal before simplifying? Root 12. Yeah, so we just do 2 times 6 in a radical. We need to simplify 12. What's the largest perfect square? 4. Yeah, this is 4 times 3. Yeah, square root of 4 is 2. Square root of 3 is square root of 3. This would be 2 root 3. Okay. I like to skip this middle step here because as I'm multiplying, I'm thinking about how 6 is 2 times 3. So if I'm multiplying, I have like a root 2 times a root 2 that's inside the 6. So when I do that, I kind of skip this middle step and go straight to there as I see like, okay, root 2 times root 2 is going to give me 2 on the outside with the root 3 left on the inside. You don't have to skip that step. the more you do this, the more used to it you'll get. When we have something like this, numbers on the inside multiply together, numbers on the outside multiply together. So my first step to this could just be writing 6 root 18. So 2 times 3 on the outside is 6, 3 times 6 on the inside is 16. Inside times inside, outside times outside. I would then need to keep simplifying. This is a 9 and a 2. Okay, square root of 9 is 3. What does that 3 do as it comes to the outside? Multiply or add? Multiply. We need to multiply. This would be 18 root 2. So everything that's going on in here is multiplication. There's no addition at all. This really means 6 times the square root of 18. Let me give you guys what to do. Go ahead and do that one. All right, what we get? 10 root 10 root 2. Nice. Again, a couple ways you can do this. You can simplify that square root of 50 that you get in there. Or if you see, okay, this is 5 times 2. This 5 is going to go with this 5. They're both going to come out of the radical. That's going to give me a 10 on the outside with the 2 left on the inside. Kind of either way is fine. We'll do a lot of these with special right triangles, so you'll get a chance to get nice and fast. Okay, last thing we want to do with reviewing is dividing. Another way to talk about dividing is rationalizing, although not always. So first of all, let's say we have root 6 divided by root 2. What does that equal? That equals root 3. Yes. Since both numbers are in a radical, we can just divide them normally. 6 divided by 2 is 3. Root 6 divided by root 2 is root 3. Let's say I have root 6 divided by regular 2. This is fully simplified. We cannot do anything with this. We can do stuff with this. We don't want to do anything with this. How about that? Let's say we have root 12 divided by 2. Root 12 can simplify, right? What does that equal? 2 root 3. Yeah, because we have 4 times 3. 2 root 3 over 2. And then? Yeah, 2's divide out. So numbers on the outside of radicals divide normally with each other. So let's say I have 4 root 10 divided by 2 root 2. Check your partner. What would this equal? Okay, so inside with inside, outside with outside. 4 divided by 2, 2. 10 divided by 2. Okay. 2 root 5. Just divide them both separately. Okay. Now, here's where we get into the next batch. If we have 2 divided by root 5 or something like this. Tim.
Don't you multiply like the top and the bottom by like root 5?
Yes. So the only problem that we have with this is that there's a radical on the bottom. And we don't like radicals on the bottom. There's actually a good reason for not liking radicals on the bottom, it's because we'll see this later on this year, but some expressions can be really, really complicated, but represented like 10 different ways that are all equivalent. But if you rationalize, then it like gets them all to look like the same thing. So I'll show you that maybe in a month. So on top of the fraction here, we have 2 times root 5. What does that equal? 2 root 5, easy. Root 5 times root 5. Root 25, which is 5, yeah. So root 5 times root 5 is just 5. Root, like, root x times root x, it's just x. Let's say we have let's do another one like this. 3 divided by root 6. Okay, go ahead and do this one. Rationalize it. Yeah, so times root 6 over root 6. Hey, why are we allowed to do this? Yeah, this is 1. It's the same number on the top and bottom. We can always multiply by 1 whenever we want. So, you know, just hypothetically, could I multiply this by log 2 of 2? Yes. Would it help me? No. But I could. Do whatever I want, as long as I'm multiplying by 1. Okay, so root 6 over root 6. What do we get on top? 3 root 6 on bottom. 6. And then yeah, so 3 divided by 6 is 1/2. Go ahead and simplify. Don't leave the 1 out front. Make sure we get rid of it. 3 divided by 6 is 1/2. What's up?
Is there a reason why we
Yeah, it's the same reason why we don't put 1x. It's not fully simplified.
Like you just did it like if I did put ways of it wrong.
It's not. It's basically not fully simplified. It's the same thing as if you said, you know, like if you just left it as 3 over 6, it's not simplified all the way. Otherwise, we could just go crazy with like putting 1 times like in front of everything, you know, and that just would be nuts. It'd be too much. It's 2 because 3 divided by 6 is 1/2. So the 3 on the top simplifies to a 1, and the 6 on the bottom simplifies to a 2. But you shouldn't write 1 in front of things. Okay. Last group here. Okay, so think about this for a second. What is the square root of 16? 4. So if I divide 16 by 4, what do I get? 4. What's the square root of 9? 3. So 9 divided by 3 is 3. So when I divide a number by its square root, I should get its square root. Because the square root is the number that when you multiply it by itself equals that number. So like 100 divided by 10 equals 10. So what this means is that if I do 7 divided by root 7, what should I get? Root 7. Because I'm dividing a number by its square root, so I'm getting its square root. So, not 9, let's say 10 divided by root 10 equals root 10. A number divided by its square root equals the square root. 13 divided by root 13. Root 13. So this is a quick way to do division. You can rationalize this. Like if I have 2 divided by root 2, I could rationalize this. Root 2 over root 2. I get 2 root 2 over 2, and then it just cancels. But that's like, you can do that. It just takes longer. It's easier to just say, okay, 2 divided by its square root equals the square root. Okay. There's our radical proof.